Hello everyone. In today's video, we're going to talk about Physics 253, Week 7, problem number 27.50. In this problem, we are asked to find the blood resistivity given a few pieces of information, such as the distance between two electrodes in a vein. So I've drawn our vein right here, and this is um, we have our electrodes here, and here's the distance of them apart, which is 4.7 centimeters, and we also have the diameter of our vein right here. So in this problem, we have to take into account chapter 27.5 of our textbook, which talks about current and resistance. Um, in this problem, we are pretty much trying to find what the resistance of the blood is inside of the vein. Um, so we're given our, as I said, the distance of the electrodes apart as well as the diameter of the vein, but we're also given the potential difference as well as the current in the blood vein. So, or of the blood in the vein, excuse me. And so from our chapter 27.5 in the textbook, we were able to find this equation right here, which will give us the resistivity of a material given resistance in ohms, as well as this is our density in ohms per meter, as well as length in meters. So to start this problem off, we're going to need to start using Ohm's law. And with Ohm's law, we are going to be able to solve for resistivity, and then using resistivity, we can plug this into our equation over here, 27.22. So just getting started here, we need to convert our microamperes to amperes, as you see I've done here. And then we can just rearrange our equation, our Ohm's law, and find the ohms. And when we find the ohms, we can essentially use this as our R in our equation here. But before we do that, we need to solve for the area, because this equation here uses area in meters squared. So by doing so, we were able to um, convert our diameter, our 2 millimeter diameter, into our 1 millimeter radius, and we're given a value in area of meters squared. And when we have this value in meters squared, we're able to rearrange our equation to solve for density, because that is what the resistivity of blood in our case. But since it's the resistivity of a material, it's going to depend on, or it's going to be known as rho. And so when we're solving for our rho here, we just take our area and multiply it by our resistivity in ohms here, and then we divide that by the length. And in our case, the length is just the distance of the electrodes converted into meters. And when we do this, one of these meters up here will cancel with this, and we are left with ohms per meter. And our answer is going to be 2.15 ohms per meter. I hope you guys found this video helpful, and thank you very much for watching. Have a great rest of your week.